Class, and then just make a power up and you can store it in class. Okay, we will. So we are going to discuss on the importance of processing of IOT. So the second topic of this module. So you know that when you are having certain set of data, and last class we have seen the information on data or the different formats we have seen. So where you know that the importance of processing the data is also very important. So some cases you need to transfer the data at a faster pace. Some cases the applications may not be that may not be the. See, in some of the applications you need to have the data transfer immediately, but in some of the applications it is not necessary to have the transfer of information fast. So like you can say that in the case of healthcare or in the case of aircraft related data or whatever it has to be transmitted at the faster space. Okay. So you can say that vast amount of type of data flowing through the internet can be intelligent and resourceful for processing technologies, and you can say that the IoT is lying on the enormous pressure. Why? Because you know that as the technology is improving, so as the technology is improving further, you know that the amount of data which is coming in the internet is too high. Bulk amount of data is coming to the internet. What will happen? It will create a lot of disturbances and all those things. So you need to prioritize which one is important and which one is not that important. So we need to classify based on the division, the process. It is three types based on the urgency of processing. It has to be processed very fast. It is not necessary to process all the information faster. Some of the information can be processed at a lower speed also, but it is not mandatory that all the information has to be processed at a faster rate. But some of the information are very critical that it has to be processed faster. For example, a person is admitted in a hospital and you are collecting the information. It is very important that that information has to be at a faster pace. Or you are in a flight and some of the operations of the flight are being controlled. So those information should reach to the center faster compared to some of the information like agricultural field. The sensor is collecting the information from the agricultural field. Those things at a slower pace also. So we can classify into three: very time critical, very time critical means what? What is very time critical? What is very time critical? See, the information which has to reach to the destination at a faster pace. See, if a person person is in a very critical situation in a hospital, and the doctor is at home, but he would like to know the information whatever it is happening in the hospital. So he need to measure all the parameters with respect to the patient, and he will be observing everything. Will stand as very time critical. For example, you are launching a rocket, and you need you can see that every time, every second to second, they will be monitoring it. Each parameter is very important. All the information has to reach to the destination in time. If it is there is a delay, what will happen? That information may not reach, and it will lead to lot of problems. So, what are the three main classifications we have here? Very time critical and normal. So let us see that the data from the sources such as flight control system, healthcare, and such sources, the medium decision support, and it is very much important. So it is the data or the information is very much critical, and it has to be transmitted at a faster speed. Okay, so we need to make sure that these data have to have low threshold of processing latency. Latency means what? See, yeah. Latency means what? Now I am just sending information from here. So the time it takes to reach to you. Okay. So you can say that delay in the network communication. So delay in the network communication is called as latency. So you should understand that the latency is very important, and in the case of very time critical, you should make sure that the low threshold of processing latency should be there. Means your communication between the nodes has to be at a faster speed. The processing has to be done at the initial stage itself, and you need to send the information. You are not supposed to delay the information at any point of time, and there should not be any processing delay. It should be in the range of milliseconds. The range should be a few milliseconds only. Okay. So data from the sources can be processed latency, and the time critical data should make sure that the transmission of information is faster. So this is what you can see here. We'll go on to the next slide. You want anything to be noted down? So it is very important for us to understand these things. So some of the data will be very time critical and normal. So let us see the next one. Okay, let us see the next one. So these data are generally, you can say that some of the information you are taking from vehicles or traffic machine, smart home system, surveillance, all these things we can consider as, yeah, this is which tolerate the latency of few seconds, so it can be considered as the time critical. Okay, so means it is important, but it is okay that slight delay here and there is okay. That's not going to impact too much. So the normal data means what? The normal data tolerance process the latency of few minutes and to a few hours, and the data associated with the domains such as agriculture and environmental monitoring and all those things. If there is a 5-10 minutes of delay finding out what is the agriculture land productivity or what is all those, it's not going to impact anything much, isn't it? But some of the information is very critical. Sometimes if a stone is coming or some thread is coming, those information and all we need to be very much precise. It's very important that those information reach to the destination at a faster speed. Okay. So you can see that the processing requirement of the data is very time critical and sources are exponentially high, and need of processing data is almost nearer to the critical in advancing and deploying the in certain domains. And we can say that the time critical data processing requirements like transmission, remote locations, and such as cloud, all this collaborative processing can be taken care. So you can say that no particular time requirement. So for processing is required some cases when we are considering the normal data. Normal data means what? For example, you are sending some information for some photo or some video and all those things. It is okay that it takes some bit of time to reach to the destination. It is not going to create any disturbances. But you are measuring the heartbeat of a person, and suddenly there is a variation. It's not that you cannot send it up. Minute is very important, and you can say that you are launching a rocket or in military-based applications. You want to fire to a certain location, so you have to be very much precise. The information transfer cannot have a microsecond delay. Also is not tolerable. So those differentiation is very important for us to make sure that the classification of data can be done and it can be transmitted at a proper speed. Okay. So that's why we have classified into three major classifications. One is time critical. First one is which one? Very time critical, and okay. So what is latency? Delay in the network of when the process of communication takes place from one end to another. Okay. So this is what we have studied in the processing of IoT. What is the next topic? So we have studied the processing of IoT. So the first and second topic of the third module is completed. So what is the next one? Processing topologies. So we'll be studying the processing topologies next. Is that done? So you can see now the processing topologies. So what do you mean by processing topologies? So let us see that identifying an intelligent selection of processing requirements. So there will be many requirements. We have two major classifications also here. One is called as on-site and another is called as off-site. Okay. So before going to that, so the processing requirements of IoT based on the critical steps, you can say they have certain architecture, and based on that you need to understand that how massive the network is and how the transmission of data is taking place, how you need to utilize the bandwidth between the connections, how efficiently you are optimize the bandwidth usage. All those things is very important, and significant amount of overall energy whatever it is consumed and you have to provide a proper and allocation processing latency. So you should make sure that your bandwidth, latency, and processing speed, entire network topology, everything has to be considered and make sure that all these things are in proper optimized manner so that you can transmit the information in a proper way. Okay, so this is what we can divide the various processing into two large categories, two large topologies. First one is on-site, another one is off-site. So off-site can be further classified as off-site processing can be topology can be further classified as remote processing as well as collaborative processing. So this is what you can say that properly designed IoT architecture. You can say that you will be having massive saving of network with respect to bandwidth, with respect to the overall energy architecture of processing. Then with respect to the latency also. If you are designing the IoT framework in a very systematic way, you can make sure that you optimize the parameters such as bandwidth, latency, then what else is there? So you can see the bandwidth, latency, you can see then overall energy consumption, architecture of providing the allowable frequency, bands, all those things can be utilized properly. So that is very important. If you do the now you may have, for example, you travel from one place to another. You daily travel from one place to another, right? So optimization means what? You make sure that you travel in a specific speed. You travel in a comfort zone. You make sure that there is no hurdles in between. You make sure that everything is smooth. So you will be optimizing your similarly in the case of IoT, you have to make sure that the bandwidth is considered, latency is considered, the energy consumption is considered, and all these things are taken into consideration. So we can say that we are dividing the two large topologies. One is on-site as well as another is off-site. Off-site is again classified as remote processing and collaborative processing. So we will be studying remote processing as well as collaborative processing in detail. So is that done? So we will see the first one on-site, and then we will see off-site, and then we will see off topologies. One is remote processing and collaborative processing. So first one is on-site. So from the word itself, it is very clear. So we will see what is on-site. This is the so what is on-site processing? Let us try to understand what is on-site processing. So on-site processing is the processing topology where you can say that the data is processed at the source itself. So when the data is being processed at the source itself. So you are not sending the data and then processing it. At the source itself, the data is being processed and then it is sent on site. On the site itself, we are processing the data and we are transmitting the information. So what you can say, the critical in applications and have very low tolerance for latencies, and latency may result from the processing hardware or the network. So you can say that it will make sure that the latency is less, and the latency mainly depends on the hardware or the network. So application, you can say that healthcare. One of the application you can say healthcare, or the second application is flight control system. So healthcare or flight control system. So in the case of healthcare, what will happen? We have been discussing this again and again. So when rapid changes can be missed, unless processing infrastructure is fast and robust enough to handle the data. So what you can say, if a slight minute information is also missed out, it is going to create a lot of disturbance in the entire system. So it is very important to make sure that there is a rapid, whatever changes is there, it has to be taken care, and there should not be any process which is being missed out. So for example, let us take an event which is happening in an industry, like suddenly a fire happens in an industry. So what will happen when the fire will happen? The temperature sensor will rise its temperature level, means it will start indicating that something has happened in that space. So the temperature will rise, and which will lead to the information. So the sensor node processing information is sensed, and it generates the alert. So here itself, the node additionally has an option to forward the data, and then it will be sent to the processing, and it will be sent to the remote infrastructure for analysis and storage. So we will be processing the information, and then we will be transmitting it further to the entire locality. So that is called as the on-site. Offsite, and what are the two classifications of offsite? Remote processing and collaborative processing. So we'll be studying those things in the next class. Okay. So we'll be having offsite processing, remote processing, as well as collaborative processing. So we'll stop it for today now. So, so you can demonstrate your mini project now.